In this video, we're going to take a look at what happens when we put two or more linear inequalities together into their own system, and how we can find the solutions to those systems. So the first thing we're going to do, just like when we started graphing systems of linear equations, with linear inequalities, we're going to start by graphing each inequality. For this first one, we started out with two simple inequalities that are both in slope-intercept form. So I'm going to do my first inequality here in red. My y-intercept is -3, my slope is 1, so I can get all my points plotted here. And if I look at that inequality symbol, it's strictly greater than, so this is going to be a dotted line. And because it's greater than, we're going to shade above the line. Another way we can check is check any point that's not on the boundary, so we could use the origin. We would say 0 is greater than 0 minus 3, that's true. So we're going to shade above our boundary line here. Alright, now we're going to graph our second line. We'll do that one in blue. So we have y is less than or equal to -5x plus 3. So we come to our y-intercept, we have a slope of -5. We've just got 2 points. And this is less than or equal to, so that's going to be a solid line. Whoa, that's way off. So we'll come, still, try it one more time. A little curvy, but gets the job done. And so we've got that, and since it's less than, we're going to shade below the line. So we're going to come down and shade all of this. Alright, so now if we look at our graph, we have 4 different regions. We have region A here, region B here, region C, and region D. If we're talking about points that work for both inequalities, we want points that sit in the overlap of the two shaded regions. That overlap is going to be here in version B, where we see both the red and the blue overlapping. So my final answer is going to be this shaded area here, and I'll do this in purple, and that is going to represent my solution set. All the points here shaded in purple are solutions to both inequalities. So just like before we were looking for a point that worked for both equations, here we're looking for the set of points that work for both inequalities. And we're going to shade that in. So my shaded region in purple is my solution set. We're looking for that overlap. Go ahead, pause the video, see if you can find the solution set to the second system here. Alright, so if we look at this system, we've got our first line in red. We have y-intercept of 2, down 1 over 3 for our slope. That was greater than, so we have a dotted line and we're shading above. And then for our second line, we have y is greater than or equal to 2/3 x minus 1. So we rise 2, run 3, have a y-intercept of -1, solid line. And again, not in purple, we're going to shade above. We look for the overlap, which is all our stuff in purple up here, bounded by those two lines. Alright, now sometimes we're going to have lines that aren't in slope-intercept form. And if we look at our first system here, we can tell that something's up right away because the left-hand side of each of those inequalities look the same. So we're going to do some rearranging here so we can graph. So we'll have -3y is less than -x plus 6. We're going to divide both sides by -3 and flip our sign. So we'll end up with y is greater than 1/3 x minus 2. And if we do our other inequality here, we're going to have -3y is less than or equal to -x plus 3. Divide and flip. Y is greater than or equal to 1/3 x minus 1. So now we're going to go ahead and graph each of those and see what this looks like on our coordinate plane. So this one is a solid line. And if we look at our next one, we have a y-intercept of -2, same slope, so these lines are parallel. This one has a dotted line. So if we were just looking at systems of equations, we would say there was no solution. But since we're dealing with linear inequalities, we have to check the shading. For this one, we want to shade everything above our red line. So I'm just going to draw some arrows to show where we would be shading there instead of trying to color the whole thing in. And for the blue inequality, since it was also greater than or equal to, we're going to shade up as well. So now we need to figure out where we would shade for both graphs. Down here there aren't any shading because we're shading above both lines. In between the two lines would only be red since we're shading above, so our solution set is going to be everything that is above both the red and the blue line. So I'm going to color everything to the blue line, and my solution ends up looking like this. So when we're dealing with inequalities, parallel lines doesn't necessarily mean no solution. It could if there's no overlap between the shaded regions, but in this case we do have some overlap. Go ahead and pause the video, see if you can graph the second system of inequalities. Alright, so we can transform our first inequality here. We subtract 3x from both sides and divide by -1, flip our sign. We end up with y is greater than or equal to 3x minus 1. Since it's greater than, we shade above our line. Then we have y is less than or equal to 3. Remember, that's a horizontal line. And since it's less than, we're going to shade everything below. And the region where those two overlap is our purple region right here. We can also work backwards. So we can take a look at each inequality, find our slope and y-intercept, think about which way we're shading, and then see if we can't figure out the system. So if I look at this first one, I have a y-intercept of 2 and a slope of -1. So that is going to be, we'll write it down here, y, we have -x plus 2. It's a solid line and we're shading above, so it's y is greater than or equal to. Then here we have a y-intercept of -3, and our slope, we rise 2, run 3, so our slope is 2/3. So we have y 2/3 x minus 3, strictly going to be greater than or less than because it's dotted and we shaded above, so strictly greater than. So our system here would be these two inequalities. If you were asked for them in standard form, you could transform each inequality into standard form. Go ahead and pause the video, see if you can identify the next system. Alright, so if you look at our top line, we have a slope of -1, a y-intercept of 1, and we're shading down with a dotted line, so that's y is less than -x plus 1. For the bottom line, we have a slope of -1 again, a y-intercept of -3, dotted line, and we're shading up, so it's y is greater than -x minus 3. Alright, now for this question, similar to the ones we did when we just had one linear inequality. We're given the inequality, and we're given a couple of points that we want to figure out whether or not they are solutions. So there are two ways you can do it. The first being you could just plug the coordinates in for x and y into each inequality and see if you get true statements. If you do for both inequalities, it's a solution. Or you can graph the system and see if the point lies in that shaded region. So go ahead and pause the video and see if you can identify which of these 6 points are solutions to the system. Alright, so if you go ahead and look at these points, we have -1, 4, which sits on our solid line, but also would be shaded by the blue line if it was not on that borderline, so that is a solution. -5, 2 is clearly in our shaded region. 0, -2 does not work because it sits on that dotted line, so that is not a solution. 0, -1 just slides into our shaded region, so it's good. -1, -1 again is clearly inside, and then if we look at the point 2, 1, it sits on the solid line, but that wouldn't be shaded by the blue line, so it's not a solution. Alright, here is a similar problem, but we don't have the graph. So go ahead and pause the video and see if you can figure out which points belong as solutions. So here we substitute in x and y values in each inequality, and we must get true statements for both, and the only point where that works is 1, 2.